One of the most dramatic moments in the history of science happened in 1939, when physicists realized that nuclear fission was real. Fission refers to the process where one nucleus splits into two roughly equal nuclei. The realization that energy could be generated in this way challenged almost everything that was accepted about nuclear physics at the time. But just 3 years later, the first nuclear reactor was created. Scientists used this to control the fission reaction and harness its power, and this changed the world forever. There are two ways of releasing nuclear energy: fission and fusion. In fission, the splitting of a nucleus generates energy. Once scientists learned to control this reaction, they were able to create energy that could be used as electricity. Though first used to make atomic bombs, fission is now used in reactors worldwide to produce heat and radiation energy. Nuclear fusion, on the other hand, is what powers the sun and stars. In fusion, light nuclei merge, or fuse, to form one heavier nucleus. This explosive energy was first used in hydrogen bombs. Scientists are still trying to understand fusion well enough to harness that energy, like they do with fission reactions. One of the next most dramatic moments in nuclear research occurred more recently. In 2022, researchers at the U.S. National Ignition Facility used 192 lasers to achieve a high enough temperature to get hydrogen ions to fuse into helium, creating an explosion that produced more energy than it consumed, a long-held goal of fusion researchers. This is another milestone on the path to channeling fusion reactions the way we do fission, which would provide another carbon-free source of energy to help fight climate change, one with even more energy potential, less radioactive waste, and no risk of nuclear accidents.